Alrighty, let's get started. Let's talk about API security, specifically how we think like a hacker around APIs and how we would go about hacking into an API and what security implications there are for us as developers and those working with and building APIs, what we need to think about when we're doing our work. So before we get into it, first of all, who am I? Why am I here talking to you? Well, I am basically the Laravel security guy. I've been a very long time PHP developer. I've been doing it for 20 something years. And I've been doing Laravel for maybe 10 years now. It's been a while. But these past 2 years, I've switched to being a consultant where rather than writing my own code, I've been reading everyone else's code and I've been finding security vulnerabilities in their code and I've been doing penetration tests on their applications. And so it's given me a view of how developers think and act and what they commonly do when it comes to security and the common flaws and vulnerabilities that they introduce just because that's just how developers work. And so hopefully I can impart some insights in my talk and give you a better idea of how a hacker would approach hacking into sites and how you as a developer what things you need to think about as a developer to keep your site secure. So who here has heard of the OWASP top 10 before? Well, it's a virtual talk. I can't see anyone's hands up, but if I did this in person, I guarantee almost everyone in the room would have their hand up. It's very common. It's one of the first places that you start when you get to security. People talk about it all the time. It's a checklist. It's a thing. It's just a big thing. It's a very common, well-known thing. So here's the list to refresh your memory. And I mean, I'm not expecting you to remember all of these posts. I mean, I don't remember all of the different points. They refresh it every couple of years, and let's face it, it's a lengthy list that you don't have to remember all the points for exactly. You work through it every so often, you read through it, it refreshes your memory, gives you an idea of what to learn, and it works really well as talk material, as instructional material, and for indicating the areas that need focus. But I guess the point I'm trying to make before I keep rambling too much is that you don't need to remember all the points specifically, but you need to think about them all when you're going through it because it can help spark ideas and think about what you've currently done and how you're working, and it'll come back in your head. Even if you don't remember it, this stuff will come back in your head when you're working because you remember the things you learned from it. So why am I talking about the OWASP top 10? Because it's not just applicable to APIs, it covers all sorts of web applications. But did you know, and I didn't know until recently, there is actually an API security version. There is the OWASP API security top 10, which is, you guessed it, the top 10 security risks that OWASP have found, and during their surveys of the industry and community, the top 10 risks they believe most affect APIs. Things that API developers like us, people that work with APIs and use APIs, develop APIs, things we need to be aware of with our APIs. So what we're going to do during this talk is run through the top 10. We're going to go from 10 to 1. I'm going to give you some examples from some of the things that I've seen. We're going to look at it from a hacker's point of view. So rather than just go, you must do blah, I'm going to try and reframe everything from a hacker's point of view so that you can better understand how a hacker would go exploiting that vulnerability so that you can protect your site from it. So number 10, the lowest down on the list, is unsafe consumption of APIs, which basically means don't trust third parties. So what I'm meaning here is that we don't trust our users. We validate user input and we escape user output. But when we're working with another API, when we're consuming data from another API, do we actually validate those values? Do we actually check that what they're giving us is safe? Because what if they've been compromised? What if someone has hacked into a third-party vendor and they're returning corrupt information or malicious information, which is causing problems for us because we're not validating it? Even if they're not being malicious, maybe it's just a mistake, maybe there's a bug, maybe there's something going wrong in their system. They could be returning information that's not useful to us, information that could actually cause problems for us. And if we're not validating the information, we could open up vulnerabilities on our end. So as a good example, I should say, let's look at this one that I found recently in a little program you might have seen, little website called Mastodon. So I saw this tweet, and it caught my eye because they're retweeting, they're posting a link to one of my articles, ironically about cross-site scripting, and it's in a language that I can't read. Luckily, Mastodon gives us a translate feature, so there's a little translate link, and I clicked on that, and that's all I saw, that line there, which it didn't make sense because the original had a whole lot more, including a script tag. So you'll see the script tag on the second line down, and that's kind of where this cuts off, which made me really, really suspicious. So I checked my browser tools, and sure enough, we have a script tag being loaded in here with the rest of the message is now being considered a script, and it's broken, so it's not displaying, it's not doing anything. We've got some errors in the console. The point is that there is script running in my browser from the translate feature. And so red flags started going off, and I thought, wonder if I could play with this. So I wrote my own post, just grabbed some words that I couldn't read, threw a bit of HTML at the end, ran it in my browser, and boom, we now have cross-site scripting on Mastodon. So you can see up there, we've got the little broken image thing that shows that the image tag is being loaded. And then in the console at the bottom, we have a content security policy violation, which means that our cross-site scripting, our JavaScript is being run, but the browser protections, the content security policy is blocking it, which is exactly what it's supposed to do. So this is a brilliant example of why you want a content security policy, because it's blocking that attack and is also showing that something is going wrong. So what's going wrong here is that when the post is being loaded originally, and we'll go back to that, it's escaping everything properly. So the script tag is being escaped, it's being displayed as it should be. But when it goes through the translator, when it goes through LibreTranslate, when it comes back, LibreTranslate is actually unescaping everything, and then it's returning the raw HTML. And Mastodon is trusting the value the response is getting, the translation is getting from LibreTranslate, and it's just dumping it straight on the screen. It's not actually escaping it again, because it's trusting it. And so because they're trusting it, it's allowing LibreTranslate to get cross-site scripting, to get JavaScript running in our page. In this case, it's a perfectly innocent mistake, problem, bug, whatever you want to call it. Maybe it's intended functionality from LibreTranslate, I don't know. The point is that they're not doing anything wrong, and they're not doing anything malicious. Mastodon should be validating that output, the response they're getting from the API, and they should be escaping on the output. So this is a vulnerability that has been fixed. There's been updates. Details are out very soon. I was hoping they'd be out already, so I can't show you the thing. But the point is that this is a known and fixed vulnerability, so I'm not really seeing anything that no one knows about. And also the content security policy protects as well. The point I'm trying to make for this is just, don't trust your third-party vendors, third-party APIs. You need to validate what they're giving you as well. Don't just blindly trust it. Number 9, improper inventory management, which basically means clean up after yourself. So we've all been there. When you're building a new feature, you're working on some stuff, and you've got a legacy version, and you've got clients that want the legacy version. And it happens all the time, especially for APIs, where you've got API v1 users, and that's the really old version. That say you've got some important clients with some old systems that are still running it, and they can't upgrade to version 2 because reasons. You've got version 2, it's the super stable one you built, it's brilliant, you love it. But there are some changes you're making, so you're working on version 3. So you've got 3 different versions of your API. You've got your legacy version that's really, really old, but you have to keep it around for your legacy users, the legacy clients. You've got version 2, which is rock solid, works well, kind of a beast. You've got version 3, your new nice version you're working on. It happens all the time, and that's why we version APIs, right? But what if your business policies change? What if the way you're building what's the word? I can't think of the word. What if your policies change and the way that you want things to work changes? And so you no longer want users to be able to be deleted. So in version 1, anyone could delete any users they had access to delete. That's the simple call at the top. Version 2, you added a token for security. You realized that maybe just having a raw delete call to that endpoint was a bad idea, and you should have some form of token to have maybe some two-factor check or a 2-step process to do deletions. So you add that in version 2. Version 1, of course, stays the same because the legacy code, legacy systems, you can't implement the token because it doesn't exist in version 1. And then in version 3, you've decided actually we can't delete users. But you've still got version 1 and 2 floating around alongside 3. So even though 3 doesn't let you delete users and 2 requires a token, 1 just lets anyone delete any user that they have access to. And you can't really hide behind the excuse of, well, no one's going to find it, because why not? There is legacy documentation online everywhere. It's really easy to find old, outdated documentation for APIs and other systems. And so if you have APIs like that floating around, someone's going to find it. And as a hacker, if I'm trying to figure out how to abuse this system, I'm going to look for old documentation. I'm going to look for old API docs to figure out what old API calls there were and which ones I can make to do what I want. And so I'll come across version 1 and I'll be able to delete the users even though I shouldn't be able to do it in version 3. Number 8, security misconfiguration, or it's not all about the code. So it's very easy as developers to focus entirely on the code, to focus on what the code is doing, what the code does, all the security stuff within the code, and ignore everything around it. And if you're working in a large team, you can often say, oh, that's just DevOps, that's sysadmin, that's all their problems, I just do the code. But you still need to care about the things, because if you get your security misconfiguration wrong, if you break the things around the code can be vulnerable. For example, if you don't have HTTPS, what happens? Well, if your connection between your client and your server is unencrypted, isn't protected by HTTPS, then someone could just sit in the middle and they can intercept your messages, they can change them, they can listen to them, and so they can do whatever they want, and you've got no control over that because you don't have an encrypted connection. So that's why you need HTTPS. But that's not really enough, because the problem with HTTPS is on the first request, unless you specifically specify HTTPS, and this is granted less of an issue with APIs than it is with standard websites, but it still can be an issue, especially with sloppy developers not putting the full URL with the full protocol in place. The first request might be HTTP only. And if that happens, then someone sitting in the middle of the request can go, great, yes, this is a HTTP only URL, there's no encryption. Then they can make the encryption connection to your server and do whatever they want with it, and it's passing through them on the way through to the client. So to solve this, you have HTTP Strict Transport Security, or HSTS, which means that it's a header that tells the browser, or tells the client, I should say, that every time you interact with this URL, with this domain, you must use HTTPS. You must use an encrypted connection. And that prevents people from sitting in the middle and going, yes, this is a unencrypted connection, and intercepting that one and then doing the encryption from them to your server. So HSTS is important, especially if you're working in APIs that are consumable through the browser, like JavaScript toolkits, things like that running on other sites. Then you want HSTS to make sure that those connections are always secure. Because if they can be downgraded, if they don't require HTTPS the whole way through, then someone can intercept the information. The other thing to be aware of here is cross-origin resource sharing. And now, as a hacker, when you're hacking into a website, you're going to pay attention to the cause headers. You're going to have a look at them. Because if they're overly permissive, if they allow everything, if they allow authentication, and they allow from these domains and wildcards and things like that, then it gives you all the information you need to break into the site because you know how to work around the cause. You can configure your requests from certain places and in certain ways to bypass the cause protections, and then you can make the malicious request that you're trying to make. So make sure that your cause is locked down. You don't want it wide open. You want it as tight as possible so that it's only allowing the very specific things that you need. All right, number 7, server-side request forgery, or simplistically, don't trust URLs. There is more to it than this, but URLs are the main reason, the main way you would get server-side request forgery happening. So when you've got a website, say we've got someservice.com, sometimes if you want to protect your API or protect your website, you'll have it behind, say, a proxy or a firewall or both, load balancer, something. And so the IP address that the user gets when they ping it is going to be a public IP address. This is going to be the IP address that they hit when they hit the firewall and the proxy and load balancer, and eventually they get to the server, which is protected behind the multiple layers. As a hacker, when you're trying to break into a site, you don't want to deal with the firewall and the proxy and the load balancer. You want to get straight to the server. Because if you can bounce over their firewall, if you can get past the firewall, then you can avoid all the security rules in there, and you can perform attacks that the firewall might block. Say they're running rate limiting in the firewall, or the proxies, proxies doing some caching or something. If you can bypass all of that and hit the server directly, you have a greater chance of actually making an effect and getting through protections. So the way server-side request forgery works is if you can trick the server into making a request for you. You need to trick the server into making a request for you. Basically, you're forging a request through the server. So we'll consider this service here, someservice.com, has a feature where it allows you to set a profile picture. And rather than upload the file directly, you can give it a URL for your file. And what it will do is go off and retrieve your image from that URL and then load it into their system. But what you're doing here is you're telling the server, go to this URL. And so by telling the server to go to this URL, you can get the IP address of the server, or at least the outbound IP address. It might not necessarily be the server. And so the way this attack works is that, yeah, you get them to ping a URL, make a request to a specific URL, and then you can see what happens from that. So in this example, it's making a request to a server I control, and in that case, I can get the IP address. And if it's just this server making the direct request, and it's not running behind some form of gateway or something, then the IP address that it gives me is going to be the server's IP address. And then I can make requests direct to that server, bypassing the proxy and the firewall. What you can also use this for is doing port scanning and looking for internal IP addresses and internal hosts as well, because you can check the response time of, say, different ports to see if it's open or closed, and you can check. Obviously, this all depends on how they handle the URL and what they do with it. But if they do it in the right way, if the URL is handled in the right way, you can learn a lot of information, and you can map entire internal networks based entirely through server-side request forgery, because you can control the URL that it's pinging, and it can tell you different information about the stuff that's sitting in there that it can see and that it can connect to. So, on to the next one. Number 6, unrestricted access to sensitive business flows. So what does this mean? It's kind of a wordy one, and I reduced this one down to prevent malicious activity, or monitor for at least. We can't really prevent all malicious activity. So what does this mean, and what is malicious activity? And malicious activity, my understanding here is that this is talking about the activity that is allowed, the system activity that the system allows you to perform, but using it and manipulating it in such a way that it can be abused or be malicious. So a good example for this is, think of a hotel bookings with free cancellation. So if you so you're in a town and you've got 2 hotels and there's a big event coming up on a big weekend, and you want everyone to stay at your hotel. Well, what you could do, if your competitor if a competitor has free cancellation, and has an API for booking hotel rooms, you could just use their API to book all the hotel rooms in their hotel out. And it's free cancellation, it doesn't cost you a thing. So you can book them all out, do it over the course of, say, a week, rotating your IP addresses and your user agents and changing all the information so it doesn't look like it's the same request. But you book all the rooms. And then everyone who's trying to book for the event, book in the town, is going to go to your hotel because the other hotel is booked out. And then right before the free cancellation ends, you just use the API to cancel all the bookings. Their hotel is empty, yours is full, you win. Really simple to exploit these sorts of things if you can find that sort of information, and it's tricky to stop, because how do you tell the difference between malicious and benign, malicious and normal requests? Because this is why I didn't really want to say prevent on its own, but have to monitor so you can track these things, and if you see the places like fully booking up, then maybe you need to do some phone calls or something like that. So it's a tricky one to solve, but it is something you definitely need to be aware of. How can my API endpoints can be abused? What functionality that users are allowed to do can be abused to do things that I don't want them to do, or impact my service in some way, or things like that. 5, broken function level authorization, which basically means don't forget authorization. Specifically, this is talking about on the function level, on the route level. So consider you've got an API like this, you've got these endpoints here, and you want to protect these endpoints. The post, put, and get need to be protected so that only users that have the right authorization can make those requests, while other normal users can use the get users or the get users ID. But what I see is very common. It is very common actually. I will say that. It is very common when I'm doing my security audits is that developers will forget authorization in places. So I'll find, say, when I'm auditing a website that has like 100 different routes, I'll find 1 or maybe 2 that's missing authorization because they forgot. And if you forget authorization on even just 1 route, there's a chance that someone's going to find it and exploit it. So what if you forgot the authorization on the post route in this request? So you got the 5 ones there. The bottom 2, you've got authorized. There's authorization running on there. But if you forget it on your post API users, then anyone create a new user. And it's really easy to forget authorization depending on how you set up your code. And as I said, I see it all the time, so it is quite easy to do. It does happen all the time. So you need to really be aware of your authorization and the fact that you're making on every request, and every request does authorize. Is the user allowed to do this? What are they doing? Because as a hacker, when you're looking around, you'll see if you see the two white routes there, you've got the get API users and the get API users ID. That'll give you the format of this resource. And so it looks like a REST API, these two. So you could try post API users. You could try put API users ID, delete API users ID, and see if any of those hit. It's really easy to protect the other routes. So obscurity isn't going to protect you if you've forgotten to authorize. Number 4, unrestricted resource consumption, which set reasonable limits. This is similar to the one we were talking about before with malicious activity, where you need to set reasonable limits in your APIs so that users can do what they're allowed to do, but they can't abuse what they've got. This is more focused on actual where resources get used up, or you get denial of service attacks, or so unintentional denial of service attacks, basically. Where a user is using your APIs quite a lot because they've got inefficient code, or they've got a really loud code base or something, and so they're doing lots and lots of requests, which is having an impact on you. And the things like pagination, say you don't have a pagination limit and then someone requests 1 million rows in a single request. Well, imagine pulling 1 million rows out of your database, throwing that into JSON, then returning it. It's going to take time. It's going to be a huge amount of data, and it has the potential to suck up all your resources and slow everything down. Or third-party API limits. Maybe you make requests for third-party API and they get billed. You get billed per API call you make. One of your customers is doing something silly and they're making lots of requests, which triggers your system to make lots of requests to your third party. You're going to get billed a huge amount by the third party because you didn't limit what your user was able to do. So yeah, you need to set reasonable limits so users can do what they need to do, but don't have them so high that users can abuse your system and cause problems for you. Excuse me. Number 3, we have probably the most wordy one of the lot, broken object property level authorization. Which, what does that mean? Well, basically, it means be careful with your data. It means be careful and watch out for data exposure and watch out for mass assignments. And they've tied those two together in here in number 3 and in number 3, so it's pretty important. And this is something that you see all the time, again, when you're auditing websites, and it's really common. So data exposure, the first part of this, is where your API is returning too much information. So for example, we look at this. This is the API response we get when we make an order. And we can see we've got the user, the current user's the name and email. Yes, that's fine. We know that information, but it's also got credit card. And you should never return credit card information like this, ever. You should never pass it around. You take it, you do what you need to do with it, and you encrypt it, you store it somewhere securely, or you forget it. You don't pass it back. Because someone could gain access to this output somehow, and then they've got the credit card information, and that information is being leaked. But also, if credit card is being loaded in the user model, imagine if you have an output that lists all of the users. What if it ends up in there? And that happens all the time, where you're just dumping your models to the output. You think, oh yeah, this model user can see that. Makes it easy. The framework you're using makes it easy to send the model to the view, send the model to the output, and it just JSONs it up and sends it out. And you've forgotten. Sorry. Excuse me. Sorry about that. All right, and you've forgotten that the user model has credit card details stored on it as well, and so that stuff is being sent out as well on all of those users. So that's bad. And the other thing, also in this example, you can see we've got admin notes, and that is another field that's internal only. That should only be seen by, by the staff of the company that is doing this. That should only be seen by the staff of the company that's running this API, not by the users. And so by the users seeing this, they're seeing sensitive information that could actually be quite problematic for the company if it gets out. And again, our example of a list of users, if that just gets dumped out, or maybe you've got admin notes for all the different users, which could have PII and other sensitive information in there, And that instantly becomes a huge problem. So data exposure is just providing too much data, just dumping too much data out, giving it away. So really, whenever you're returning any data, you need to be aware of every single field that you return. Only return the fields that actually need to be returned. If there's no reason for it to be there, don't include it. Because a hacker, someone who's scanning your API for information, is going to find that information. And another thing that you do as a hacker, and we'll touch on this in one of the remaining points, is that, see, we've got the user ID there and it's giving us 123. What if that was a UUID and a really long, complicated random string? Well, we're getting our own UUID, so that's meh. But what if we're getting the users list and the users list includes all of these UUIDs? Suddenly we have a map to all the supposedly random and unguessable IDs for all the different users, and we could use that later. Now, mass assignment is the other part of this point, and this is where, rather than returning too much information, you're accepting too much information. So it's the reverse. So you've got this endpoint, and this is a real example from one of the sites that I audited, where they had an API endpoint for registering a user. So you send your username, your email address, and your password, and it would register your user. But they were just grabbing that and dumping it straight into the user record to create the user. They weren't validating the existence of different fields. They weren't specifically pulling different fields. They were just dumping the whole lot in there. Sure, they validated the email was a valid email address and the username was a string and the password was longer than 8 characters and had something else in it. But they weren't checking the actual fields themselves, which meant that all I had to do to get an admin account in this system was add that. Simple as that, adding in role admin. And it set the admin onto the user record. It passed role admin into the user record and it's set in the database. And when my newly created account was created, I was a full administrator from this. That's mass assignment. Really, really easy to fall into this trap. And it's also, for those who use Laravel specifically, or I'm sure other frameworks would have this as well, where Laravel has this feature where on user models, you can define fillable properties, fillable attributes. And these are the ones that can be loaded by mass assignment when you're creating or updating fields. And so a lot of people think that that will solve the problem, that you just set fillable on the right fields and then you're happy and good, it'll protect you. But that's global across your whole application. And so it's kind of pointless in my view, because if you've got a user registration form here, you only want username, email, and password to actually be fillable. But if you've got an admin section with users in there, and you want to fill user, email, password, role, notes, and a few other fields, well, you set it, and if you set fillable for this, for the admin section, then your user registration can use fillable too. And that's what happened here, is that they had fillable open for their admin section. And so the registration, which needed a different fillable, a different set of fields that could be filled, was inheriting that and was vulnerable. So rather than doing it on the model level, I highly recommend that you do it in the request level, in the controller level. When the request comes in, validate every single parameter. Make sure that the only parameters in the data that you're passing around that you're using are the parameters that you actually want, the parameters that you need. And don't just allow everything, because that's a recipe for mass assignment, is just allowing everything, lets everything in, and then lets this sort of thing happen. All right, number 2, broken authentication, which I had a lot of trouble coming up with an alternate name for this one, so I just went with authentication is hard. Because authentication is hard. It just is. And just quickly, and I should have explained this before, but authentication is verifying who the person is. Are they who they say who they say they are? So do they have a valid password or a valid token? Do they have a valid 2-factor authentication? It's just who they are. Authorization, which we've already touched on, is ensuring they're allowed to do what they are doing, or what they are trying to do. Maybe would have been a better way to put that. So you authenticate users to figure out who they are, and then you authorize users to work out if the user that you know they are is allowed to do what they're trying to do. And so this one is talking about authentication specifically. And so we're talking about things like protecting login forms, so credential stuffing, brute force attacks, allow weak passwords. We're looking at protecting tokens, so don't pass them in the URL. You need to validate tokens to make sure they're valid. There are tricks you can use with JWTs, JSON Web Tokens, to forge them and trick them and weaken their security. So you need to be careful that you're not vulnerable to those. You can have sensitive operations like changing email addresses and passwords, which you only want users to do once they've been confirmed and authorized and validated again. You also need to hash passwords properly, don't use weak encrypted keys, etc. There's a huge pile of stuff around authentication that is hard. That's why I said it's hard. And I mean, it's just something you have to work on, something you have to be careful of, and you can't just, you can't just do a simple, quick job. You have to take time in this. You have to take time building your authentication system, because a hacker is going to poke it and prod it. In most cases, your authentication system is what the hacker attacks first. So they'll get to a login form and they're going to try a credential stuffing attack or a brute force attack. They're going to, look at URLs and say, oh, this requires tokens. What if I remove the token? What if I send an invalid JSON web token? Does it still work from that? Are the encryption they're using, is it crackable? Can I break through these things? And a good example from this is when I was auditing a site, and I use this in one of my other talks as well, actually, is that they were requiring signed URLs. So the URL had a specific token in it, a signature that needed to be there in order for the URL to work. But the original version of this code didn't have that. They didn't include that. And so when they were building this version of the code, when they were updating the code and adding in their feature, they put in a legacy check and they said, only if the signature is there, then validate it. If the signature isn't there, don't validate it. But they forgot to remove that code. So years later, after the URLs without the signatures were no longer being given out, the code still said, if the signature isn't there, if the signature the code still said only validate if the signature is there, which meant that all I had to do to bypass this protection, and it was actually for an email address confirmation link, all I had to do to bypass that and confirm any email address I wanted was remove the signature. And that was it, because they'd forgotten to remove that. And that's all part of authentication. And they had forgotten to authenticate the user via that token properly. And there was a hole in there. And this is something that a hacker would definitely try and break through and focus on, because these are often the first way in to get past the initial layer. All right, we're up to number 1. Broken object level authorization, which when I read this in the list, I thought, oh, that sounds curious. I wonder how that relates to insecure direct object references. And it turns out they're the same thing, basically. It's just a different name for it. And I think they went for the different name because it ties in with the format of some of the other points they've used through this list as well, which have a similar sort of broken something level authorization. So what is insecure direct object reference? Well, I'm going to summarize it as don't trust user input. It's a bit more targeted than that, but as number 1 on this list, don't trust user input, I think, is the key takeaway. So if you forget everything else I've talked about today, remember that you don't trust user input. So how does broken object level authorization or insecure direct object references work? Basically, they rely on this. So as a hacker, when you're breaking into a website, when you're looking at a website and you look at a URL like that, you will immediately see that you've got there an incremental or some form of ID at the end. And that is the user input. That is still user input, even if it's part of the URL, even if it's something that you generate and pass through the user, it's user input. And as a hacker, all you need to do is change the number. And so if it's an ID, so if it's a numerical ID, say it's 1,325, as a hacker, what we're going to do is change that number to say 4,000 or 2,000 or 1,000 or pick any number. And people do write scripts that go through all of the different integers and make requests to that URL. And if this URL is missing its authorization, which we've talked about before, if it's missing that authorization, then it means that that request is going to return that record. And then you have insecure direct object references, or what do they call it? Broken object level authorization. Because you're not authorizing that object that should be accessed from that user. And I see this all the time. It happens so often, and it's because it's so easily overlooked. It's in the URL. It's not one of the parameters that you're manipulating in the controller action. It's already been handled when the request comes in many cases. So yeah, but now I also mentioned before about UUIDs in our data exposure. And so people often say when they get faced with this example and IDORs and broken object level authorization vulnerabilities is you should have used a UUID. Rather than using a numeric incremental ID where it's very easy to increment and decrement numbers, what if you used a UUID, which is a lengthy string that's kind of randomly generated? It's really hard to guess. There are an insane number of combinations, so you can't just brute force all of them to check the request. But if you combine this with data exposure, then your list of users that gets returned is going to have UUIDs in it. And I've found this on multiple sites that I've been working on, where some pages in the application will give me the full list of UUIDs. And once I have that full list of UUIDs, all I need to do is put it in the URL. So it's no longer a secret. The UUIDs are not secret. They're not supposed to be secret. They're designed as an identifier that is universal across multiple systems and has more randomness and avoids collisions, unlike a simple numeric ID. That is the thing about them, but they're not secret. They're not supposed to be secret. They're not, and yes, you can't guess them, but it doesn't mean you can't find them, because in most cases the application is going to give them to you. Then you can go find the UUID from where it's giving it to you, dump it in the URL, and you've got yourself the record you're not supposed to access because the authorization is missing. Because this URL, this route is missing the checks that say, should this user access this resource they're requesting? And as I said, I see it all the time, and I totally get why it's at number one. It's the top of the list because it is one of the most common things that we see when we're auditing these sites. So there we go. That is the OWASP API Security Top 10. Fantastic list. Definitely go check it out and work through it with your application in mind, with your API in mind. And if it helps, you can use my version of it, which are these ones here. I've tried to summarize them in kind of simplistic ways. It's overly simplistic, so realistically, you should be working off the main list, but I find it makes it easier to remember if you give them the simplistic names like this. So yeah, that's it. So yeah, thank you very much, Ashley. I'll just pop it in this for a little bit longer in case you want to grab it, but it's a video so you can pause it, so pause it in your own time. Thank you very much for listening. I hope you learned something from that and that you're going to go away and look at your APIs with security eyes, with hacker eyes, and look at the ways that a hacker could break into your application, break into your APIs, and how you need to harden it and make changes so that you're more secure. And it can protect you from hackers doing what hackers do.